Okay, so these are examples over lesson 4.4. The title of the section is Multiplication Rules and Conditional Probability. And we've got this table where we've got sophomores, juniors, seniors, and we've got them divided up to males and females. So far what I've done is I totaled the males and came up with a total of 300 males. I totaled the females, 270 females. I totaled those numbers, we have a total of 570 students. And I also totaled the sophomores, juniors, and seniors, and you can see their respective totals there. Now, this is called conditional probability because there's going to be some conditions given. For example, first part here, if a person is randomly chosen, find the following probabilities. The probability that the person is male, given that he is a sophomore. That means only consider the sophomores. Only look at this number, total sophomores. Ignore the rest of the data. So if we're only looking at the sophomores, 180 is going to be our denominator on this answer. Okay. Now we want the probability they're male. So how many males are there in the sophomore class?
100.
100. So given that they're a sophomore, means only look at the sophomores. There's 100 males. So the answer is 100 out of 180. Divide both of them by 10, you get 10 out of 18. Divide again by 2, you get 5/9 as our final answer. Any questions about A? Make sure you get that written down so you have an example to use on the homework. Okay, B. The person is a junior given she is a female. So if it's given that she is a female, what number am I going to use for my denominator here?
270.
270, right. Only consider the females. Ignore the rest, okay? I'm going to cross this out. Only going to look at the females if it says given she is a female. So I have a total of females, 270. And then I want the probability the person is a junior. So how many junior females are there? 120. So your answer is going to be 120 over 270. Divide them both by 10, that's 12 over 27. Divide those both by 3. 4 ninths is the answer.
Okay.
Any questions about that? So 4 ninths. C. Let me clear this off here, I think. Whoa. Give me a headache, probably. Okay, we're doing C. Given she is a senior. Okay, let's just give you guys a minute to try this one. Give you just like 1 minute. Try to come up with the answer for C.
You just do 120 on everybody.
Yeah.
How many people are there? 70.
Alright, that wasn't much time. But given she is a senior means look at the total number of seniors, which you can see is 110 plus 70 or 180. What's the numerator going to be on this one? 70, right. What's the probability she's a female? Remember, we're only looking at the seniors, so there's 70 females out of 180 seniors. Divide by 10, that is going to be 7 over 18 is the final answer. Any questions about that one? Okay, next up. D, find the probability the person is a junior female. Now notice this one does not say given. If it doesn't say given, you use the total number of people, which, if we add up all these numbers, what do we say that total was? Right, we said 570. So if it doesn't say given, you have to assume that they want you to use all students, which is 570, which is not too far from the size of our school. A junior female means they're both, a junior and a female. So how many junior females do you see up here? 120. So just put 120 over 570. Divide by 2, that's 12 over 57. Divide those both by 3, that's 4 over 19 is your final answer. Any questions on that one? All right, let's keep moving. E, probability the person is a male senior. Again, it doesn't say given, so we're going to assume that we're using all 570 people here, all 570 students. And that's what you get if you add up all the numbers. How many male seniors are there? 110, yep, so 110 over 570 comes out to 11 over 57 is your answer. Divide both by 10. I think one of you guys do the computer work here. Okay, number 5. Last problem here. Sorry, I'm kind of playing with this new software. It takes me a little bit to get used to it. Okay, number 5. Now this is a lot like what the beginning problems are going to be on lesson 4.4. If 90% of the students own a cell phone, and you randomly select 3 students, answer the following questions. What's the probability that all 3 will own a cell phone? So you have 3 people. I'm just going to make 3 blanks here. So this is a little different than the last assignment. The last assignment had a lot of ors in it. This means what's the probability the first one's going to own a cell phone, and the second one, and the third one. In probability, or means add, and means multiply. So you walk up to the first person in the hallway and say, hey, do you own a cell phone? There's a 90% chance, or 0.9 chance, that person's going to say yes. You go up to the second person. Hey, do you own a cell phone? 90% do. So again, there's a 90% chance that person's going to say yes. Same thing with the third person. You ask them if they own a cell phone, 90% chance they're going to yes. Say yes. If you want to know what's the probability that all 3 will say yes, you multiply 0.9 times 0.9 times 0.9, or you could take 0.9 to the 3rd power if you wanted to. And if I remember right from first hour, that answer is 0.729.
Yep.
Right, okay. So, just almost 73%. Almost a 73% chance that all 3 students, or all 3 people, whoops, that's supposed to be a 9, isn't it? Let's see if I can edit it. 0.729. All right. B. What's the probability that at least one of the 3 does not own a cell phone? So let's say I make a box here. In this box, I'm going to put groups of 3 people. Over here on this side, I'm going to say, all right, your groups of 3. Any groups where all 3 own a cell phone, go stand on the right side. Actually, the left side. If all 3 of you own a cell phone, I want you to be on this side of the box. What percent? What's the probability you'd be standing over here? 0.729, right? 72.9% of the groups would have all 3 owning a cell phone. The other possibility is if you're over here, would be that if you're over here, that instead of all 3 of you owning a cell phone, at least one of you doesn't own a cell phone. So these 2 events are complementary, or complements. Either all owning a cell phone, or at least one not owning a cell phone. So how would I find this answer for over here?
1 minus.
Good. 1 minus 0.729. That'll be the answer to this question. 0.271. So the answer for B, 0.271. Almost done, Mr. King, if you want to talk to him in a minute here. Part C. What's the probability that none own a cell phone? So you walk up to someone in the hallway. 90% do. What's the probability they're not going to own a cell phone? 10%, right? 90% minus 100%, or 100% minus 90%. So you go up to that first person. There's a 10% chance, or 0.1 chance, they're not going to own a cell phone. Second person, same thing. 0.1 chance they're not going to own a cell phone. Third person, you ask them, do you own a cell phone? 0.1 chance they're not going to own a cell phone. What I want to know is what's the probability that the first one, and the second one, and the third one don't own a cell phone. When you hear the word and, you multiply them together, and that will give you 0.001. Or in other words, as a fraction, that would be 1 out of what? 1 out of 1,000. So if I went up to 3 people, only 1 out of 1,000 times, all 3 would not own a cell phone. Okay? Not very often. Last one. What is the probability that at least one of the 3 will own a cell phone? Well, again, let's put these groups of 3 in a box. And I say, if your group has nobody that owns a cell phone, go stand down here in this end of the box. Okay? What percent of the people, or what's the probability you'd be in that box? 0.001, yeah. There's only 1 out of 1,000 groups would have nobody with a cell phone. So the complement of nobody having a cell phone would be at least one of you having a cell phone. So what would be the probability being in this bigger area here? Right, 1 minus 0.001 or 0.999. So that's the answer to part D. Anybody have any questions about that? Do you need to talk to me or these guys, Mr. King?
I just need to I just got the roster from NICC, and I just want to make sure that